Today's video is about computational thinking. So computational thinking is a way of problem solving. To be successful with computational thinking, it's going to use a combination of logic and maths. And there's three methods of computational thinking that we're going to have a look at today, which is abstraction, decomposition, and algorithmic thinking. So the first fancy word we're looking at is something called abstraction. And as a definition, it's removing unnecessary parts of a problem so that you can just focus on the main problem. Now that's a really common question that comes up on your paper 2 exam as a definition. It's usually a 1-mark question and this is the answer. So to actually use abstraction, you need to work out what is relevant in the problem and then what's not relevant. So you get rid of anything that's not relevant and then you can just focus on the main problem. Now this is especially important when you're thinking about programming. Sometimes people have great ideas and they'll spend a long time with their programming trying to do it. If that's not actually solving the initial problem you set out to do, then there's just no point in doing it. So you just need to be able to focus on the main problem, not get distracted, and remove anything else that's not necessary. Another really common exam question is they'll give you a scenario and you have to use abstraction to say what's relevant in that scenario and what's not relevant. If we just stick to the same rules that we've already talked about, then you just need to think about what the scenario is, think about what it's already told you that is going to be relevant in solving that problem, and then anything that's not, you can just say you've got rid of that. You don't need to focus on that anymore. The next part of our computational thinking is called decomposition. Most people seem to remember this definition because it reminds them of a dead body. And if you think a dead body is going to decompose, it's kind of the same thing where it's going to break down into smaller pieces. And it's the exact same thing with our problem solving. If you started with a large problem at the top, you might want to break that down into smaller problems so that it's easier to deal with. As general benefits of decomposition, if you're going to distribute these small problems to other people, it's going to get solved faster. And also generally smaller problems are solved faster on their own. And they will all feed into solving the overall main problem. So if you combine this with abstraction, you've already picked out what's important and removed anything that's unnecessary. And now that you've got that, you can break that down into smaller problems and then distribute that to a team of people who can work on it. The final piece of our computational thinking is called algorithmic thinking. As a definition, an algorithm is a set of instructions that you can follow to solve a problem. Quite a lot of time in lessons, teachers use the analogy of making a cup of tea, and then they'll talk about having those problems in the correct order to successfully make your cup of tea. For your exam, there are different methods of algorithmic thinking where you can show logically the steps of your problem solving. We're going to have a look at these in the next video, but the methods are going to be flowcharts, pseudocode, high-level programming, and exam reference language. Okay, so we've got a practice question for this topic. So a library has a computer system to record details of the books it has. Each book has the author, edition, book title, year published, and how many times it has been borrowed. Each book is given a rating based on author and how many times it is borrowed. This is quite a lengthy scenario, but this is the kind of thing I'm talking about that's been common in previous exams that you might get, and you have to use abstraction on this scenario. So I know there's a lot of information to take in here, but you might want to pause, you might want to have a look and maybe think about what's going to be relevant for these answers. So question 1, define the term abstraction, just a simple definition. And then question 2, give one example of how abstraction is being used in the design of the rating system. Okay, let's look at the answers then. So question 1 was define the term abstraction. So it's focusing on the main parts of the problem, removing unnecessary detail. And question 2, give one example about how abstraction is being used in the design of the rating system. So they're focused on the author and the title and how many times it's been borrowed. You can ignore the year it's been published and the edition. It's told you that in the scenario what the rating is based on.
Today we are looking at writing algorithms. So there's different ways of writing an algorithm, but we are going to focus on both flowcharts and pseudocode. It's worth mentioning that we can write them in a high-level programming language like Python, and there's also exam reference language, which OCR have got their own, but we're not going to look at that, purely because you can still get the marks in writing pseudocode or high-level language. Writing an exam reference language is almost like learning an extra language on top of that. In my opinion, stick to learning less and you can still get full marks. So when you're writing an algorithm, they should always include input process and output. An input will usually come from the user. They might be prompted to type something in. It could be an integer, it could be a string, and so on. Most of the time that input is then stored in something called a variable so we can do something with it. So that's where processing comes in. The value might change, other values might change, and if there's any maths going to happen, then this is the time when it will happen. Finally, you will display what you've done to the user. That's usually so they can see that it's worked, whatever they've tried to do. We're going to start by looking at a flowchart example. This flowchart doesn't use all of the symbols possible, but we will be going over those as well in this video. So to begin with a flowchart, you always use an oval at the very beginning, which we've just written the word start inside it. To show the direction of flow, we use arrows between the different symbols. Now this flowchart is going to be checking a username and password to log into a device. So because the user is going to be prompted to type in their username, we've written that into a parallelogram and we've written inside it input username. Username in this case will be used as the variable which will store whatever they've typed in. In a separate parallelogram, we're then going to allow the user to type in their password. This will be stored in a variable called password, but again inside our parallelogram we've written input and then password. Following on from this, we've got the decision symbol. This is the diamond shaped symbol. In this decision symbol, we are going to check if the username is correct. So to do that, we're using the exact word that we used before to store it, which is username, and we're asking a question. Is username equal to Mr. Moore CS? Now you'll notice that I've got a double equals sign in there. That's not a mistake. That's to do a comparison to see if it matches. So if the answer is yes, it will move on to the next decision symbol. But if the answer is no, it's going to display a message, which is our output, and it's going to say to them, try again. And following our arrows, it's going to loop back to allow them to type in the username again. But if the username is correct, then we're going to move on to our decision symbol, which is going to check the password now, asking the same kind of question, is the password equal to cool beans? If the answer is no, it's going to output the message, try again, and just go back to the beginning. But if the answer is yes, it will display a nice welcome message saying output welcome. It's also not a mistake that we're using a parallelogram for an output as well. This is used for both an input or an output symbol. Following that, we've just got an end because that's the end of our algorithm. Another symbol that's quite common that we're going to talk about is called the process symbol. So your process symbol is used for any instructions or any actions that just take place as part of your algorithm. This would include assigning variables. If your variable isn't an input that the user is typing, you can do it separately in a process symbol like this. In this example, I've got two variables that have been set. We've got num1, which is equal to the integer 5, and num2, which is equal to the integer 10. Another example you can do is any calculations. Let's say in an algorithm we wanted to add the two numbers together. So I've got a new variable which is called total equals num1 plus num2. That kind of calculation that takes place is going inside a process symbol as well. Another symbol we've got is called a subprogram symbol. Notice that this one looks just like a process symbol, but there's two vertical lines either side of it as well. Now let's say that you've got two flowcharts that are running alongside each other, but you only want one of the flowcharts to activate at a certain time. That's when you call a subprogram, and that's what this symbol is used for. If you reach a point in your flowchart where you want to call the other flowchart which you've got running alongside it, you can use this symbol. The other flowchart has usually got a name so that you can put the name inside this subprogram symbol, and then you can call the other one to activate it. Okay, now we're going to have a look at something called pseudocode. Now pseudocode is very similar to the English language, and it's actually usually very similar to Python programming language. Even if you're familiar with a different programming language, you should still be able to look at pseudocode and understand what it is trying to say and do. It's kind of like a universal language that even people from all different backgrounds can understand. Now there's two parts to your second exam paper, Section A and Section B. In Section A, it will say things like this: write an algorithm in pseudocode and then you will put your answer. Where if it's in Section B, it will ask you to write in a high-level programming language like Python. So make sure that you read the question carefully so you know which bit it is that you're writing down in your exam. So we're going to work through this example together. This was a 3-mark answer on a previous paper. So it says to store hello, which is a string, in the variable word1. Then store everyone in the variable word2. Then we've got a programming word, concatenate word1 and word2. That means to just squash them together to store hello everyone in the variable message. So to do this, it's going to look very similar to what we wrote inside the symbols in our flowchart. So word 1 equals hello, word 2 equals everyone. Here's the concatenate part of it, where we've been told to store it in the variable message. So we're going to say message is, which is the equal sign, word 1 plus word 2. That's how you concatenate it. Now notice on this one, it doesn't actually output this to the user, but it doesn't ask us to do that in the question. So we just need to make sure that we stick to the question, don't add any extra functionality, and then you'll still get all marks. If you accidentally then outputted it to the user, maybe write in print or the word output because it's pseudocode, you wouldn't lose any marks for that, but you're adding extra unnecessary work to yourself, so I wouldn't recommend it. Okay, so we've got an exam question to practice. We're going to do a very similar to the one we just looked at. So look at the following instructions. Store the string good in a variable called word 1. Store the string morning in a variable called word 2. Concatenate word 1 and word 2 and store the result in a variable called greeting. Here's a little bit extra though. Store the number 3 in a variable called repeat. Then we're going to create a new variable, final message, by repeating the greeting repeat times. That's not a typo. Don't forget we've stored the number 3 in the word repeat. Okay, let's look at the answers then. We're going to store good in word 1. We've got word 2 equals morning. Then we've got greeting equals word 1 plus word 2. Don't forget that plus sign is your concatenate to squash things together. Then we're going to store the integer 3 in the word repeat. And then finally, we've got final message equals greeting multiplied, which is little asterisk, repeat. If you were interested, let's look at the flowchart version of that. Now, interestingly, unlike before, this has got all process symbols pretty much compared to what we didn't see one in our earlier example. So to begin with, we've got word 1 equals good, which is going in a process symbol. Word 2 equals morning in a process symbol. Greeting equals word 1 plus word 2, which is our concatenation. Because it's like a calculation, it's going inside a process symbol. We're going to store the integer 3 in repeat, which is another variable, so that goes in a process symbol. And then finally, we've got our variable final message, which is greeting multiplied by repeat. It doesn't ask us to output at any time, so we don't need to use our parallelogram. We can just end. Today we're going to be looking at trace tables. A trace table is a tool used so you can keep track of what a variable is doing as a program is running. It's quite often used if you're having any problems with your program and you want to figure out exactly the moment where it's not acting the way you want it to. So we're going to look at an example about what it might look like on your exam. Here we've got some pseudocode and we're going to write the trace table out for what this pseudocode actually does. So if we just talk about the pseudocode first, we've got two variables at the beginning. We've got counter and we've got total. So we've got a while loop here, which means it's going to repeat a section of our code. And in this case, while the counter is less than or equal to 5, it's going to repeat. And then as part of what happens as part of my loop, total is going to increase each time. And it will output the total, which means it's going to show the user what currently the total is. And then we're going to add 1 onto the counter each time it loops. So with that in mind, this is our trace table that we're going to fill in. It's just going to store all of the values of the variables along the way and what the output will be. So to begin with, your counter is at 1. We're going to add 1 onto the total because that's what the counter currently is at. It's at 1 and the total's at 0. So in the total box, we'll put 1 and then the output is just going to be whatever the total is, which is going to be 1. Now notice on this column on the left hand side, it's called iteration, which means that's our first iteration of our program. Now we're going to do it again, but we'll see some different results. So the counter increased by 1, which means it's now currently at 2. But because we're doing total plus counter, we're going to do 1, which is what it's currently at, plus 2. So the total is now at 3, which means my output is also going to be 3. We're going to add 1 onto the counter and then start again. So for our third iteration, our counter is currently at 3. We add our counter to the total, which means our total is now at 6, which means the output is currently at 6. We add 1 onto the counter, and then we're on our fourth iteration. The counter is currently at 4. The total of 6 added to the 4 gives us 10, so our current total is at 10, which means my output is 10. We add 1 onto the counter, and then we're on our last iteration. So our counter is at 5. Our total was currently at 10, so it's 10 plus 5, which gives us 15, which means that the output to the user is 15. So this is what a completed trace table looks like. It would allow the user to see exactly what is happening with all of the variables and outputs throughout the whole program. If this wasn't what the user was expecting, at least they now know what's going wrong and how they can fix it. So we've got an exam question to practice. It's going to be quite similar to the previous one, but maybe slightly easier because we've only got one variable and one output that we are recording in the trace table. To begin with, we've got a variable called number and it is storing the integer 10. While the number is greater than 0, we're going to output whatever the number currently is, and each time it iterates, we're going to take 3 off our number. So complete the trace table to show the values of the number and output at each step of the loop. Okay, let's go through the answers then. So to begin with, we had number was at 10, which means the output was at 10. Then we're going to subtract 3 from the number, which means that the number is now at 7. So we output 7 because the number is currently at 7. We take another 3 off, meaning that the output will be 4 because the number was at 4. We take 3 off, and then we're going to put the output of 1 and the number at 1. That's when our while loop would finish, because while it's greater than 0, it was going to loop itself, but once we remove 3, it will be lower than 0, which means that's the end of the loop. Today we are looking at sorting algorithms. In terms of what a sorting algorithm actually is, it can sort information into a way that we want it to. There's loads of different sorting algorithms. Some of them are faster than others, but for the exam we need to know about 3, which is the bubble sort, the merge sort, and the insertion sort. We need to be able to describe the different kinds of sort. Sometimes you're asked to actually carry out one of the sorts, but sometimes you're asked to just describe one, or sometimes you're asked to compare one to another one. So we need to have a really good understanding about what each of them do, how they work, and then be able to carry them out as well. So we're going to start with the bubble sort. We're going to talk about data here and how data can be put into an order. It might be alphabetical, it might be numerical, and so on. Now for a bubble sort, we're going to start at the beginning of the list. That first value will then be compared to the next one to it, or the proper word that we're going to use is adjacent data. If the value in the first position is larger than the one next to it, it's going to swap. You will then look at it in the next position, and if it again is larger, it will swap again. Now it will keep acting like this and keep comparing to the adjacent data. If it isn't bigger than the next piece of data, then it will start swapping the next largest one, and so on. Once it reaches the end, there'll be no more checks to do on that, and that means that's one pass. So you'll be going back to the start of the list, and you'll do the whole thing again. You'll check the first position, compare it to the next piece of adjacent data, and so on. So we're going to have a little practice of this so we can see what it looks like. Here we've got some data which is not sorted. We're going to start by looking at the 2 in our first position. We're going to look at the adjacent data, so what's next to it. It's a 4, which is higher than 2, so it's not going to move. So then we're going to look at the 4 and compare it to the 1. Now 4 is bigger than 1, so they are going to swap. Now at this point, the 4 will be compared to the 5. 5 is bigger than 4, so there's not going to be any swap. We will then compare the 5 to the 3. 5 is larger than 3, so they're going to swap. Now we've done a full pass here, so we're going to go back to the beginning. So 2 is compared to 1. 2 is larger than 1, so they're going to swap. You can see it's actually nearly sorted now. 2 gets compared to 4. There's no swap because 4 is larger than 2. 4 then gets compared to 3. They're going to swap because 4 is larger than 3. And our data is sorted using a bubble sort. So let's look at the advantages and disadvantages of a bubble sort. So to begin with, it's easy to learn and code, especially for beginners. And it works particularly well on small or nearly sorted lists. At a disadvantage, it's a pretty slow sorting algorithm. Other algorithms like the one we're going to look at next, the merge sort, are much faster. Okay, let's move on to the merge sort then. This one uses a technique called divide and conquer. So when we start with our list of data, we first of all need to separate it all and divide it. You would then pair the individual elements and place them in order. They will keep combining until they reassemble and they're fully sorted. Let's have a practice with the merge sort then. Here we've got our unsorted data and we're going to start by dividing it. So we split them into 2 separate groups like this. We're then going to split them down even further. Finally, we're going to put them all into individual elements of data. Now we're ready to start the merge part of this. So 2 and 8 were already in order, so when they merge, they're going to stay looking the same. The 1 and 4 got compared. 1 is smaller than 4, so it's going to be reordered as 1 and 4. The 5 and the 3 we're going to get compared. So they get reassembled as 3 and 5. And then the 7 and 6 get compared and they get reassembled as 6 and 7. We then merge the green and the yellow groups together, which gives us 1, 2, 4 and 8. Then we merge the blue and the pink sections together, which gives us 3, 5, 6 and 7. To finish with, those two groups will get merged, giving us our list in order. So let's look at the advantage and disadvantage of the merge sort then. So it's very efficient for large lists. It's much faster than the other ones that we're going to look at today. And it always takes the same number of steps. So we did it with a little example, but let's say you've got tons of data, it will still take the same amount of steps to actually sort the data. So we've got some disadvantages of the merge sort. It does use more memory. If you were going to code it, it's a little bit more complex. Finally, we're going to have a look at what is called the insertion sort. So it is faster than a bubble sort, because most of them are, but it's slower than the merge sort. If the value that we're checking is smaller than the value that we are looking at, it will keep moving left until it meets a value that is less than it. Once it's in place, we will keep doing that with the next piece of data until all the data is sorted. So to begin with, we've got our data which is unsorted. We're going to start by looking at the 4. That's got nothing to the left of it, so it stays where it is. We then look at the next value, which is the 6. The 6 is larger than the 4, so that's going to stay where it is as well. So our first swap will come in place where we look at the 5. It's going to be compared to the 6. It's smaller than it, so it will swap with it. It then checks it against the 4. It's larger than it, so it'll stay where it is. We're then going to look at our next piece of data, which is the 3. The 3 is smaller than 6, so it will swap. The 3 is smaller than 5, so it will swap. The 3 is smaller than the 4, so it will swap. There's nothing left to compare against, so we'll move to our next piece of data. So the 8 was bigger than the 6, so it stays where it is. So we looked at our next piece of data, which was the 2. It's going to swap with the 8. We compare it to the 6. It's smaller than it, so it's going to swap. The 2 is smaller than 5, so it will swap. The 2 is smaller than 4, so it will swap. The 2 is smaller than 3, so it will swap. Nearly ran out of space on my slide, but that is our sorted data. So let's look at the advantages and disadvantages of an insertion sort. So it performs very well when the data was already almost in order. It's also easy for beginners to learn how to code it. So disadvantages of an insertion sort include, if it's got a large list, it will start to become inefficient and slow down. We've got some questions to practice then on this topic. So question 1, complete a bubble sort on the following. And the next question is, what is an advantage of using a merge sort instead of a bubble sort? So you'll have to compare the two. Okay, let's go through the answers then. So for our bubble sort, you can see the 3 got compared to the 4. There was no swap because 4 is larger than 3. So then the 1 got compared to the 4, which then swapped. 4 then gets compared to 2. It's larger than it, so it's going to swap. 4 gets compared to 5, and there's no swap, and that is 1 pass. We then go back to the beginning. 3 gets compared to the 1. It's going to swap because it's larger than it. And then the 2 gets compared to the 3, and it's going to swap because it's larger than it. And that is our sort done. So for our advantage of using a merge sort instead of a bubble sort, the merge sort is much more efficient with large amounts of data. That'll get you 1 mark. A bubble sort will take much longer. That will get you your 2nd mark.
Today we're looking at searching algorithms. So an algorithm is just a set of rules that can be followed to achieve a task. So when we're using searching algorithms, we're thinking of a set of rules that we can follow so that we can search for a particular piece of data. Now this piece of data could be in some sort of list or array, and it might be good for looking up to see if something already exists in a database or in some sort of data set. Now for your exam, you're going to need to know 2 main searching algorithms, which is the binary search and the linear search. Now for the binary search, we have to be able to perform it and show the steps of it, whereas the linear search, we more just need to be able to talk about and just explain how the steps would work. So let's start with the binary search. Now one of the most important things we need to remember about a binary search is it has something called a prerequisite. This is something that has to have happened before a binary search can take place. So the prerequisite of a binary search is the data has to be sorted first. At each step, it will halve the amount of data that it's got left until it finds what it's looking for. So this is really good for large data sets. A disadvantage is what I've previously mentioned, the fact that the data has to be sorted first before it can take place. But if you've got a really large data set, then it's going to still work out time-wise a lot faster. Another disadvantage would be it's more complex to actually code. So for beginners, it's not going to be an easy job. Let's look at the steps to perform a binary search then. So this is a typical kind of question you might get in your exam. A list of sorted numbers are stored in an array. Show how a binary search would find the number 18. So the very first step we would do is to find the midpoint. You would have a 0-based system. In the actual first position, that is actually position 0. then 1, 2, 3, 4, 5, 6, and 7. Now we need to be able to find our midpoint, and we're going to use a tiny bit of maths to find this point. If you made it clear that you understood that you needed to find the midpoint first, then you didn't need to use the math. So you could just literally write find the midpoint or put a little arrow pointing to the middle point. But if you were going to find the midpoint, we would do the very left side, which is 0, added to the very right side to begin with, which gives us 7. Now we've used a word here, which is div, and we're going to div 2. Now this does mean divide, but because we're using div, it's going to return the whole number only. So in this case, 7 div 2 would give us 3.5, but we're going to ignore the 0.5 because it only returns the whole number. So we found our middle position, which is going to be 3. Now it's a good idea on your exam to actually show what you're doing throughout the steps. So you can actually remove data, put lines through it, put arrows. It's really helpful for the examiner to show your understanding. So in position 3, we are storing the integer 12. Now we know because we sorted this data that it must be greater than that. So at this point we can discard the entire left side, including position 3, because we've already checked there. So all I'm going to do is put a line through it and cross that out, and we're left with this data. Then all you've got to do is repeat the steps until you find what it is that you're looking for. So our new very left position is position 4, added to our very right position, which is position 7. Div 2 is going to give us 5. We know now that it's going to be less than what's in position 5, which was 21. So we're going to discard that whole side on the right, including position 5. At this point, we've only got position 4. That is both our left and right side now. So 4 add 4 gives us 8. Div 2 is going to give us 4. So finally, we are pointing at the position where we wanted to find our data. So you could just write 18 has been found. The next searching algorithm that we're going to look at is a linear search. Now a linear search will start at the very first position and it will just move along one position at a time until it finds what it's looking for, or it reaches the end without finding it. Now the biggest advantage of this is that the data does not need to be sorted first, and it's much easier to program, so it's quite simple to understand. But as a disadvantage, it's much slower on larger lists. So compared to the binary search, which got rid of half the data each time, let's say that the data that you're looking for is right at the end, it's going to take a lot longer to find that piece of data that it's looking for. So for this one, like I said, we don't usually have to show the steps for a linear search, so we just need to be able to explain it instead. So let's look at a practice question together. Explain why a linear search would be more suitable than a binary search when using an unsorted list. So it's only a 2-mark answer, and what you could write is a linear search does not require the list to be sorted. A binary search only works on sorted data, so cannot be used without first sorting. So we've got a question for you to practice using the binary search. A list of sorted numbers is stored in an array. Show how a binary search would find the number 7. Okay, let's go through the answers then. So like before, we need to start by finding our midpoints. We can do this by doing 0, add 8, which is our very left position, added to our very right position. Div 2 is going to give us 4. So 0, 1, 2, 3, and 4. So this is our current midpoint here. Now we know because the data's been sorted that it must be less than that because we are looking for the number 7. So we are going to discard the entire right side, including position 4. Then we're going to use our new left side added to our right side, which is 0 plus 3. Div 2 is going to give us 1. So we are now looking at position 1 and we have found our data. So 7 has been found. That's the end of the question.
Today we're going to be talking about what Python programming is, and I'm going to be showing you how we can download it so you can start learning how to program in Python. So in terms of what Python programming is, it's just a programming language, and it's sometimes referred to as a high-level programming language. Now what that means is that lots of the words in the programming language are actually really close to the English language. This makes it automatically easier to understand than other programming languages, especially in comparison to low-level programming languages. As a real-world function about why you might learn Python out of all the programming languages, it's used in developing apps, it's used for websites, it's used in developing AI, and tons more.
As I said earlier, as it's so close to the English language, it's actually one of the easier programming languages to learn. So it's a really good one if you're just starting to program or just wanting to learn the basics of programming. Now I'm going to show you how we can install Python so we can use it. To be able to start coding in Python, we need to install something known as an IDE, or an integrated development environment. This is just a really fancy way of saying this is where we type our code. And the place that you type your code has got extra little tools which will help you code. So it makes it easier, it'll make it easy to spot mistakes and so on. All you need to search in your browser is install Python. And you can see here, it's the top link, download Python. Now the latest version is going to be right there in front of you in this nice big gold button so you can download it. You double click on the file that's being downloaded and it comes up with this box. Now if you're just getting started and you don't know loads about it, I just recommend clicking where it says install now. So it took just over a minute to actually install and it came up with this message. You can see it does link you to online tutorials and documentation if you're brand new to it. So you can have a read through that, or you can carry on watching videos as well. It's all good ways to learn. Now that you've installed it, you'll be able to see it by clicking on start, going into all, scrolling down to the letter P, and you can see it there, Python 3.13, which is the latest version. In this folder, you've got these different options. It was the manuals that it was talking about, but also idle is where we're going to be typing our code. This is the IDE that we mentioned earlier, but this is Python's one. There are other IDEs available that you can download. Some people prefer different ones for different tools that it comes with. This is fine for beginners. So when it first opens, it doesn't look too impressive. You're left with this. So for example, if I just type in 2 + 10 and hit enter, it will execute that command straight away and you'll see the result outputted to you. The other mode, which is where you're going to be typing most of your code, will be on script mode. So if I click on file and then new file, you're left with a big blank box, which is where you're going to put all of your code. When you run your code, it will ask you to save it, and then the results will appear in the other window. So in the next video, we're showing you how to output information and what that actually means. And that's how we install Python so we can get started with coding. Today, we're going to be looking at what is meant by an output. Last time we installed Python and we're going to start using it today. One of the first techniques that we normally learn how to do is outputting information. Now what this means is that we're going to give some information back to the user, usually show them something. This could be showing results, it could be giving an instruction to the user, or it could just be a little message to the user that something's gone wrong. There's loads of other examples as well. These are just some common ones. Like every programming language, Python has its own way of outputting information, and we are going to use a word called print. So this is known as the print function. And to make a function work in Python, you will need to have an open close bracket at the end of a function. Just as a reminder as to where we're going to actually type in our code, we're going to click on file and then new file, and this is the window we're going to type our code in. This is so we can type multiple lines of code and then we can run it when we are ready to test our code. So like I said, the keyword we're going to try out today is print. So this is what it looks like. We type the word print and you'll notice it's changed color. If it's changed color, it means you've spelt it correctly and you've used all lowercase. If you put a capital P, you'll notice that it's changed back to black. That means Python doesn't recognize it anymore, which means it's a mistake. Also known as a syntax error. A syntax error is when you've not followed the rules of the programming language. So Python syntax would be having print all lowercase and we spell it correctly. Now if I just want to display some sort of message to the user, I now need to open my brackets and I'm going to do speech marks. This is so I can start typing in my string, which is what will contain what I'm going to display to the user. So my message is going to be hello world. I'll do another speech marks because that's the end of my string, and then I'm going to close my brackets. So if I want to test my program now, I'm going to need to run it. And you can see that I've not saved it yet, which is why it says untitled at the top here. So I'm going to click on run and then run module, or you can do F5 for short. It is going to ask you to save. Save it anywhere you want, documents, desktop, wherever you can find it easily if you want to carry on the same one. I'm just going to call it outputting information. And what you can see is that it's outputted onto the shell, which is the other side, which we mentioned in the last video. Now, because it's displayed my message correctly, hello world, it means I've got no errors and everything worked as it was supposed to. This would be the message that was being displayed to the user. Now, your code works in a sequence. It's going to start at the top and work its way down. Unless you use a different technique, which we're not doing in this video. We'll do that in a later video. So what I've done, I've typed in another print statement, which is print, brackets, speech marks, I am Mr. Moore, speech marks, close brackets. And let's run this code now so we can see what happens. So like before, run module. You've already given it a name, so it'll just update the save, but it will ask you, do you want to save, so we can run it. And as you can see, it says hello world, and then underneath it, that's when it says I am Mr. Moore. That's because it starts back at the top again, and then just the next one underneath it. And today we're going to be looking at what is meant by a variable, and we're going to be using some in Python. So a variable will store information.
It's a location in memory, so we can store some information. It might be a string, it might be an integer, it might be the user's input, and so on. Now you will store this information so you can reuse it later on. And you can also store information so you can perform some calculations or do some updates within your program. Now while we're looking at variables today, it's a good time to talk about something called maintainability. Now this is just good practice while you're programming. Other people might look at your code, and it makes sense to make your code really easy to understand so it's nice and easy to read and they know exactly what's going on, and that's what's called maintainability. Now the way we're going to do that is by using nice neat code, and we're going to leave some spaces in between things, which is known as white space, to make it just easier on the eyes to read. I'm also going to show you today how we can add a comment using hash so that you can explain what is going on in your code. So if, for example, somebody's looking at your code and they're like, I'm not sure why they've done that, you can explain that in a comment so they know exactly what your thought process was. Sometimes that's also a good idea if you couldn't get your code to work, and you can leave a comment and say, this is what I've tried, can you help me with this section here? And they know exactly where to look then. Finally, like I said, we are going to be using variables today, and you can call a variable anything you want, but it makes sense to call it something that is related to what it is that you're storing, which will just make it so much easier when somebody else looks at your code because they'll know exactly what it is being used for. And also for you later in your code, if you're going to refer to it, it's easier for you to remember, which will just speed up the whole process. So we're going to start off by adding a comment, and to do this we're going to use hash. Following hash we can just type in whatever the comment's going to be that other people might want to read. My comment is going to be global variables to let other people know that this is going to be the set of variables that I can use anywhere within my program. So now I'm going to start putting my variables in my program. I'm going to start by naming one surname, which I think is a really appropriate name for the information I'm going to store. I'm going to store inside a string Mr. Moore. And you can see that I've got speech marks both sides of it, so it's turned green, which knows that it's going to definitely store a string within my variable. Surname is the variable. Mr. Moore is the data that is being stored within the variable surname. What I'm going to do is output my information just to make sure that what I've typed so far hasn't got any errors in it, which is a really good way of testing your code, and it's good practice as you're developing a program just to keep running your code so you can see if it's working correctly. So, like from the last video, we're going to use print to output some information, and then going to put my variable surname within the brackets. Let's run our code to see if it outputs the information correctly. So I'm going to run my code, it's going to ask me to save it. I'm going to call it variables example, and as you can see, it's displayed Mr. Moore, so it was outputted correctly. So we're going to look at storing some other data types now. We've already looked at the data type a string. Now we're going to look at what we call an integer, which is a whole number. So the whole number that I'm going to store is the house number. Notice I've put two words together, and just so you can see the second word, I've put a capital N there. This is a technique known as camel case. So house number equals 54. Now notice I didn't put speech marks on this. I've just put a number, which means that Python will recognize it as a whole number straight away. So the variable house number is now storing the integer 54. The next data type we're going to look at is something known as a float or a real data type, which is a decimal in Python. So for this one, I'm going to call my variable hours worked, and I'm going to put 8.5. Because you've got the decimal point in there, Python will automatically recognize it as a float, and that has been assigned to the variable hours worked. Finally, we're going to look at a data type known as a Boolean data type. The Boolean data type can hold the true or false value. This is really important for different techniques that we're going to look at in later videos. So my variable for this one is going to be employed, and I'm going to put the word true. Now notice that true has got a capital T on it. This is following Python syntax. This is not a mistake, which is why it's changed color because Python recognizes it. It would also work if I've done a capital F on false. Now I just want to point out the maintainability technique that I've been using throughout. You can see we've got some white space here underneath my comment. We've also got some white space here after my variables before my print statement. This is just good programming practice so that other people will be able to easily read my code. I've also used suitable variable names for all the information that I'm storing, which just lets other people understand what my code is supposed to do. If I'd put x equals 8.5, that could have meant anything, whereas we know that hours worked means how many hours somebody's worked. It's just much so easier to understand. So we're going to finish by combining the two techniques that we've talked about so far. We're going to output some information and put a variable at the end of it. So I'm going to write nice to meet you, speech marks. I'm going to put a comma, which is Python syntax. It's following the rules of the programming language. And then I'm going to write surname, which is the variable I want to put after my string. Have a guess what it's going to say when we run our code, and let's see if you were right. So it says, nice to meet you, Mr. Moore. So it's used the stored information from surname and put it at the end of our string. Today we're going to be looking at string manipulation, which includes the length of a string, changing it from upper and lower case, string slicing, and concatenation. So string manipulation is a term that is given to when we are doing anything with our string, and we know that a string is anything in Python which is included in your little speech marks. It will often turn green if you're using idle. The reason we would do this is because it will help with basic data validation, checking that it's right or not. It might be able to change what is going to be displayed to the user if you only want to use part of the string, and so on. And sometimes we might need to logically use part of a string in different programming tasks that we've been given, especially in exams. So today we're going to be having a look at how we can see the length of a string. We're going to be looking at how to convert a string into uppercase. We're also going to be looking at how to convert it into lowercase only. We're going to be looking at string slicing and something called concatenation, which is a nice big fancy word. So to begin with, we're going to be looking at how we can check the length of a string, which is how many characters are currently inside the string. And to do this, we're going to be using a Python keyword, which is len, L-E-N. So I've got a very short program here where I've got a variable, which is name, and I'm storing Alice as a string inside my variable. Now I'm going to use the technique which is known as len, so I can see how many characters are currently in that string. So let's run our program with len like this, and then we've got name, the variable, inside an extra set of brackets so that we can use len properly, so we can check how many characters are in that variable. So the result of running this program is it's outputted a 5. And if we just go back to my program and quickly check, we've got 1, 2, 3, 4, 5 characters, which is why it's outputted a 5. So it's being correct, it's counted it exactly. Now, included in a string, it does count spaces as well. So let's just do one more example of this. If I put a space at the end of Alice and then run it again, let's see what it outputs. And you can see this time it's outputted a 6 because the space also counts as a character. A common use of len might be to check the length of a password to see if it's got enough characters inside. The next string manipulation technique we're going to look at is converting everything into uppercase in a string. Now I'm going to do this in a bit of a different way. I'm going to change the variable itself and what it's storing underneath, and then I'll display it separately in an output. So to update the variable, I'm going to say name, which is the variable, is now going to become whatever name currently is, but with .upper at the end. And .upper is our keyword that we're going to use for our string manipulation to make everything uppercase. And notice that following Python syntax, you do need to open and close your brackets at the end of that to make it work correctly. Following that, the line underneath it, I've put print name so that we can display what is currently stored in the variable name. Let's have a look what happens. So because it's running in a sequence, it's gone from the top and displayed our 5 again because there's 5 characters in Alice. And then underneath it, you can see it's fully displayed our string in uppercase. This is a really good technique if you're doing any validation to check what the user has entered. And if they've been going up and down, uppercase, lowercase, uppercase, lowercase, you can just put all of that into uppercase so that it's easy to check something against it. Our next technique is very similar, but we're going to change everything into lowercase, and we're going to do it in the same way. We're going to update our variable so that everything will then be lowercase, and we can display our output to make sure that it has worked correctly. So let's run our code. We're going to use .lower this time instead of .upper. .lower is our keyword to make everything lowercase. And don't forget your open close brackets at the end of it. From the top, our sequence, it's displaying that we've got 5 characters in Alice. It's then going to show everything in uppercase. And then you can see it's updated our variable again to make everything lowercase. Now we're going to have a look at a technique called string slicing. Now string slicing is where you can just display or pick out parts of a string. Now it's important to note here that actually in the first position, the first index of the string is actually position 0. So for example, position 0 in our name Alice would be A for Alice. So we're following correct Python syntax. To do this, we need to use square brackets, which is different from the brackets we've been using so far. So I'm going to use print because I want to display something. I'm going to put our variable in, which is name. I'm going to open my square bracket and I want to display anything from position 0, and then I'm going to put a colon and then say where it's finishing. Now I'm displaying only the first 3 letters here. Even though there's a 3 there, which seems a bit confusing, it will stop at the one before it, and then you'll close your square brackets and then we'll see what happens. So let's run our code.
So from the top, again, we've got 5 characters, uppercase, then lowercase, and as you can see, it's only displayed the first 3 characters using 0:3. If you wanted to display any more, you would need to use the next number up and so on. Another string slicing technique is where we can go from the back instead. Now what I'm going to do is do just -3 with a colon at the end, and what that will actually display is the last 3 characters of our string. So if I run my code, let's see what we get. So you can see this time it's displayed ice at the end of our program. If you wanted to pick out any other letters around the back end of the string, you could do -3 to -1, and we can run that and see what happens. You can see we've been left with IC, which is this bit of our string just here. For our final technique, we're going to have a look at something called concatenation. Now this is where you're going to attach and join together 2 variables or 2 things. So what I've done is I've stored 2 variables. I've got name equals Alice, and then I've got surname now, which is storing the string more. Now to display these, normally we would do print name comma surname. Let's run it and see what we get. And you can see it's put Alice Moore with a little space between them. Now to successfully concatenate it, we need to use a plus sign instead. The plus sign is what is going to do concatenation in Python. So let's run my code one more time so we can see what happens. This time you can see there's no space and they've successfully been concatenated. Today we're going to be looking at different types of error, including a syntax error, runtime error, logic error, with examples in Python, with full explanations about what each of them are and why they might occur. So when we're programming Python, we have lots of different types of errors that will pop up. It's really normal when you're programming, especially when you're just learning program for the first time. It's very easy to make a mistake. As the result of an error, the program doesn't run as you expect it to, or could often crash. There's 3 main types of errors that we're going to have a look at today. We've got a syntax error, we've got a runtime error, and we've got a logic error. So first of all, let's have a little talk about what a syntax error actually is. As a definition, it's when the rules of the programming language aren't being followed. Now, every programming language works in a bit of a different way, and you've got to structure it correctly. So if you're missing, say, a symbol, or you've spelt one of the keywords incorrectly, then Python or whatever programming language it is won't recognize it, and it will stop your program from running correctly. So I'm going to show you a really simple syntax error that is very common. Now, one of our keywords that we've already looked at is the word print, and we know that to lay it out properly with the rules of the programming language, we might type in something like hello world inside speech marks, and then that would usually end like this. So at the moment, everything looks right. To cause a syntax error, if we forgot the bracket off the end of this, that would be classed as a syntax error because we're now not following the rules of the programming language. Now, in terms of what actually happens when we try and run a program with this, let's have a look. So at the moment I'm using idle, and this is the kind of message that we see. It tells us that the bracket was never closed. Now this technique is actually known as debugging, where you run your program and it comes up with a simple message and it's going to try and tell you where your error actually is. This has gotten better over time and it never used to be so specific, but this one's really clear that it knows that we've forgotten to close that bracket. We just need to fix it by closing the bracket. Another common one is people accidentally put a capital letter at the beginning of it, and you can see that the word print is now not recognized. It's a different color. So if I try and run this program now, this is the kind of message that we would get. So notice it didn't pop up in a separate little box saying syntax error this time. You've got this big ugly load of red text. Now, even though this one wasn't as concise as the last one, it does say that on line 1 is where our error has occurred. And you can see at the bottom it says name print is not defined, which means it doesn't recognize the word print and why it was there. All needs to be lowercase, and it has come up with a suggestion right at the bottom. Did you mean print or lowercase? So really good programming practice is while you're writing a program, you should run your program regularly so that you can see any errors, any syntax errors that you might have so far. The next type of error we're going to look at is something called a runtime error. Now, as the name suggests, this is something that will happen while the program is actually running, and it will stop the program from working. It'll make it crash. The most common way that this happens is because of a bad input, and if you remember, the input actually comes from the user interacting with the program while it is running. So what I've done here is I've used a technique called casting. Casting is when you change the data type of a variable from one thing to another. I've got age as my variable, so it's going to store the result of the input from the user. And in Python, an input automatically is assigned as a string, but we are going to tell Python that now it's going to be an integer, which is a whole number. So it's going to expect us to type whole number. So let's run our program and see what happens. So here's my program running. So the first time I run it, I'm going to type in I am age 20 and press enter, and you can see I've entered a whole number, which is what I was expecting. If I press enter, the program finishes and everything was fine. So this time I'm going to type in the word 20 as text, and when I press enter, we get our error. This is a runtime error. So unless you know what you're looking for, this one's not as obvious as an error, and some people might think, well, I don't understand why it's an error, I've typed in something correct. But if you look down at this bottom message that it's got for us here, invalid literal for int with base 10:20. So it doesn't like the 20 that we've typed, and it knows it was something to do with the integer that we've put in our program. So you've got to be careful when you're typing in things to interact with your program, usually as an input. You need to make sure that you've got the correct data type and you're not going to annoy Python a little bit with it. The final type of error that we're going to look at today is something known as a logic error. This is where technically everything in your program follows the rules of the programming language, so there's no syntax errors, but it doesn't give us the result that we were expecting. This one's going to check if the age that we enter is greater than or equal to 18, so 18 or above. It's going to display the message to us, adult. But if it's anything else, which means if it's under 18, it will display the message child to us. So let's run and see how this program should look. So how old are you? If I put in 20 and press enter, you can see it displays the correct message of adults. I'm just going to run it one more time and I'll show you if I enter an 18, it also accepts it as some boundary data. Right on what we should be allowing, so 18 and above, it still says adult, so it's working correctly. Now if, for example, I use the wrong symbol, this one now reads as less than or equal to 18. So even though that is a valid thing that I can use in Python, for this program, it's not going to make sense what the output is. Let's have a look. So hello world, how old are you? This time I'm going to say 20 again. We know that that should be an adult, but when I press enter, it's coming up with the message child. And if I run it one more time, and this time I'm going to put I'm 10 years old, should definitely say child. It's actually going to say the opposite and say adult. So we know that logically this doesn't make sense, and that's why it's a logic error. So finally, I just want to have another recap about the word debugging and what that actually means, and methods of debugging that we can use to try and fix the errors in our code. So as a definition, it means that we are finding and fixing errors in our code. Quite often different editors, a bit like Idle or Thonny, have different means of debugging and will try and give you hints as to what your error actually is, and it's actually considered a tool of an IDE, which is our editing environment. So there's other ways that we can also debug. As I mentioned earlier, we're going to run our code very often to test it to see if it works. That's one really good method of debugging. Reading your error messages to figure out what it is that's actually going wrong is another good method. What you saw in that last program that we were running was another debugging method, which is where I'm trying to type in different things to see what the outputs actually are. I entered 20, I entered 18, I entered 10. They were all different inputs so I can test my code thoroughly. Another method might be using print throughout your code so that you can check at which point in your code what is happening. Maybe with your variables, what value they're currently holding, and so on.
Today we're going to be looking at another programming construct which is known as selection. This is the technique of using if, elif, and else in Python. So we've already looked at a programming construct called a sequence, which is where one instruction follows on from the next one in your programming. And the most common technique that we're going to use to do that in Python is known as if, elif, and else, or sometimes just if and else. So we are going to be making use of something known as a Boolean expression, which is how it's going to check if a condition is true or false, and depending on what the condition outcome is, it will then choose one path or another one. So there's going to be a lot of keywords that I'm going to be using throughout this video, so I'm just going to run through them really quickly so you know what I'm on about. So the first one is known as a condition. Now this will be our first example we'll see in Python, but it's where we're going to check the Boolean expression, and that is our condition. For example, we might check if the age is over or greater than 18. That is the condition. If that is then true, it would do that thing. Now, sometimes, like I said, you might do one path or another one. That's also referred to as a branch sometimes. So depending on the outcome of the decision, it's either going to do one branch or another one. The final keyword that we're going to be using a lot today is known as indentation, and this is like a little gap which follows our line where it checks our conditions. It'll be really obvious when we look at the Python in a moment. Python syntax, which is the rules of Python programming, if you've not got your indentation, it will come up with an error. So we need to make sure that we've got our indentation in the right place so that it works correctly. So take a quick screenshot. These are all the different types of Boolean expressions that we could use when doing selection. I've also included logical expressions in here as well, which are like and, or not. So it always makes a lot more sense when we see an actual Python version of it. So let's have a little chat about that. So in this program, we've got on line 1, we're going to ask the user to enter their age. And you can see I've used casting on here, which is int, to make sure that Python knows it's an integer, a whole number that's going to be entered by the user. Here is our keyword that we're going to be using for selection. We've got if, which are popped on line 3. Now, when you read these out loud, they make a lot more sense. So if the age is greater than or equal to 13, and, which is our logical expression, the age is less than or equal to 18, it will say teenager. So if it meets those conditions, that the number that they've put in is between 13 and 18, it will say teenager. So to add in extra options of conditions that we want to check, this one's saying if the age is over 18, and we've used elif for that. It kind of means else if, but you would write elif to make it work in Python. So if the age is over 18, then it's going to say adults. Finally, anything else that they put in, it must be below 13 because we've covered all other options. So if it's anything else, it will just say child. So let's run this and see what happens, and we'll try some different test data so we can see all the different options and whether they come out or not. So this is the first time running it. It says at the bottom here, enter age. So I'm going to put in 14, and it says teenager, as I would expect it to. Let's run it again. So this time I'm going to put in some boundary data. Let's put 13 because that's right on the edge. Still says teenager, which is correct. So I'm pleased with that. Okay, this time we want an age which is going to display our middle option, which is going to be adult. So let's go for 20. And it's correctly displaying adult, which is good. And then finally, let's go for something below our teenager. So let's go for the age 8, which should display child. Perfect. So as you can see here, we've tried all different branches. We've got it to display the word teenager, we've got it to display the word adult, and we've got it to display the word child, all separate depending on what I did and what I entered. And these are checked by these conditions that I mentioned earlier, these Boolean expressions, which is like the greater than or equal to sign or the less than or equal to sign. And for this example, I also showed you a logical expression, which is this word and, to make sure that it was checking both of those conditions. One thing I want to point out, which is something that lots of people miss out, is this second variable age that I've got here on this first line. So if I got rid of that, this is the most common thing that people write, which is actually a mistake. So it kind of reads like you would expect it to. If the age is greater than or equal to 13 and less than or equal to 18, display teenager. But that won't work. You do need that variable in there again. Otherwise, it doesn't know what to check for the second condition. So just make sure that you've got this one included as well. We're going to look at another program which uses selection now. And in this one, there's a few more techniques that are just very useful to you that you might be able to use when you try out selection yourself. So I thought I'd show you this one. So in this one, we've got to start off with the user's going to be asked to enter their name. And notice I've not used any casting this time. We've just used input so that they can type in a string, which is going to be checked. Let's say this is going to be checking what they type in. If they accidentally don't type something, that's what this does. If the name is equal to, and then 2 speech marks. Now what that means is it's checking if it's empty. And if it is empty, it's going to display the message to them. You didn't type anything, which is a really good validation technique just to see if they've actually typed something that's expected. The next branch that we've got on here is going to check if the length of the name is less than 2 characters. So len is checking the variable name and how many characters it's got in it. And if it's less than 2, we're going to assume that that is not long enough. Less than 2, which means it would just be 1 letter or below. So that wouldn't be enough. So enter at least 2 characters for a name is what it's going to display to them if they type that. It might be a typo. Maybe they accidentally typed in 1 letter and pressed enter and so on. But we're going to assume that it's not allowed in this program. So it's going to come up with an error message.
we're going to assume that everything else that has been typed is allowed, and it's just going to display the message saying nice to meet you if it's anything else, which means that it's going to be over 2 characters and it's not an empty string that they've put in. So let's give this a go and see if it works. So enter name, we're going to start with Mr. Moore. Nice to meet you. So it's accepted that, it's absolutely happy with that. Let's run it again. This time I'm just going to press enter straight away and see what happens. You didn't type anything, so it can see that it was an empty value. It didn't like it, so you didn't type anything. And then finally, we're just going to put X as our name, which has only got 1 character. And it says enter at least 2 characters for a name. So all 3 branches are working correctly with the criteria that we've put in. Today we're going to be looking at using a list in Python, which isn't to be mistaken with an array, but it's very similar to how an array works. We're also going to look at 2D arrays, and we'll give them a go in Python as well. So far in Python, we've been using variables all the time, and we're going to continue to use something very similar to a variable today, but we're also going to include multiple elements that we're going to store within the one variable, and this is known as a list. Now, I mentioned earlier that an array is different from a list, but they work in a very similar way. An array has to be one data type only, whereas a list can be multiple data types and can store multiple elements inside the one thing. They're also referred to as mutable, which means you can change them, add or remove items to them after we've created them. Okay, so let's have a look at a little Python example of them. So as you can see here on line 4, this is the list that I have created. So I've just called it my list, which is a bit like a variable. It doesn't have to be called my list. You can call it anything you want. You could call it numbers, for example. That would also be fine. But I'm going to keep it called my list because you can see I've done a few different things with it as well, so we'd have to change them all. Okay, so we've got my list equals, and then inside the square looking brackets, not the rounded ones, the square ones, you can see I've got my different numbers that I've stored, my different integers. And you can see that I've got a comma to separate them. Now, what's really important is knowing that these have got what's known as an index number, which is whereabouts in the list they are. So in the first position is position 0. The second one is position 1. Position 2 and position 3 and so on. So in this little example program that I've got here, if I just run it, you would see what happens when we do print, which is to display. So we can display the list itself, and then I'll show you what happens when we do print and then display the list, but just with the 1 inside square brackets there, and we'll see what happens there. I'm just going to remove this for now so we can only see this. So this is what it looks like when you run this type of program. So if you display the whole list, it will look like this, look kind of similar to what it does in the Python program itself. You can see the square brackets, and then you can see each of the elements that are inside of the list. And the next one, where it's displaying just the 20, that's because we've displayed what is in position 1. So we said earlier that position 0 is the 10, and then position 1 would be the 20, which is why it's displaying this 20 here. So other things that you could do with your list, here is an example of adding something to the list. So we've already created the list here, and we're going to use something known as .append, which is to add something to our list. We are going to add the integer 50, which will add it in at the end after the 40. We will then display the whole list so you can see what it looks like to make sure that you know it's definitely been added at that point. And then we'll see what happens when we display what's in position 4. So here's my program running from the top. So here is it to begin with. Then we displayed just position 1. Then here is our updated list where it's been appended to it. And then here is position 4 showing that the 50 is definitely a part of our list. You can also see another example that I've added in at the bottom here, which it says .pop. Now pop is a way of removing something completely from the list. I wanted to remove whatever was in position 2. If we just go back and look at our list, we had 0, 1, 2. So 30 was in position 2, and then you can see when we display the list right at the bottom, 30 now doesn't exist. It's not part of the list anymore, so it removed it whilst the program was running, and then we displayed what was left, which was these positions of the list. Okay, so just to finish, I want to talk you through something known as a 2D array. So here is another example of a 1D array, which is this time instead of storing integers, it's storing names. So you can see we've stored the name Alice, comma, Bob, and then Charlie. And if I was to run this program now, it will display what's in position 0, so it will just display the name Alice. Now the 2D array is a little different because when you've got one set of square brackets, that's a 1D array. If you've got another set of square brackets inside those square brackets, that's what makes it a 2D array. So it can go across multiple lines. I've laid it out like this to make it look a bit like a grid because I feel like it's just an easier example to follow, but you don't have to do that. So I've opened my first square brackets, which are here. And then inside it, you can see in this first row, I've got integers 1, 2, and 3. Then I've got 4, 5, and 6, and then 7, 8, and 9. Let's display using print what's in our grid. Line 0 would be this first one, but then in position 2 would be this one within line 0. So you can see in this case, it will just display the 3 because we've got similar again. The first one's always 0, so 0, which is this first line, and then position 2, which is this one just here. So as I said, it doesn't have to look like a grid. If that's confusing you, you can just do it all on one line like this. This is the exact same grid, but as you can see, it's just all one together. So I've got open my square brackets here. I've then done another one here, and then here is our first row like it was before. It's just all on one line. I think it looks a little neater like this, but it's completely personal preference. That's completely up to you. So you can see when you're storing lots of information, it makes sense rather than doing multiple variables, you can just do one list, which is going to store all of that information for us, including multiple types of data. So it's really, really useful.
Today we're going to be looking at for loops, which is a count controlled loop. We're going to be looking at a few different types of for loop, looking at iterating through a string, looking at lists, and using in range, everything that you'll need to know for your exam. Before we look at for loops today, we're going to have a little reminder about programming constructs. So the first programming construct that we looked at was a sequence, which is where your program instructions will just happen one instruction after the other in a sequence. The next one that we looked at is something called selection, which is the technique where we used if and else so that you've got different branches that can do one thing or another depending on a condition. And the final programming construct that we're looking at today is a programming construct called iteration. And if you think of the word reiterate, which is where you repeat something, this is where it gets its name from. And it's where you can repeat a block of code. And in this case, we're going to be looking at one type of iteration, which is known as the for loop, where it will do it a set number of times. So we're going to start with a really simple for loop, and you can see I've only got 2 lines of code that I've written here. And when I keep saying this word for loop, it's because at the beginning we've got a keyword in Python, which is the word for, which goes right at the beginning of the line. Next to the word for, we've got a variable. So in this case, I've called my variable x. Lots of people like to use the letter x just purely because it's used a lot in maths and they're quite familiar with it, meaning it can just mean any number. But you can call it something else if you want. If you wanted to call it tree, it will work just in the same way. But in this example, I would also have to replace this with the word tree. So after the variable, you can see I've used some code that says in range. Now we use this in a for loop to specify how many times we want it to repeat the set of code. And in this case, inside our brackets, I want to say I'm going to start x at 1, the number 1, and it needs to end before the number 11. And to be able to see what is happening in this loop, I've used print just to display whatever x is currently at. Part of a for loop manages incrementing what x is automatically within the loop. So after its repeat, the x will then go from 1 to 2 and then 2 to 3 every time it iterates. And then once it's repeated the set number of times that we've said, it will then finish the program. Let's see it working. So I'm just going to hit run at the top, and if you look at the bottom in the shell, you can see it very quickly produced numbers 1 to 10. One thing I should point out is at the end of this, you've got a colon, and the colon is Python's syntax. So without it, it will come up with a syntax error. And anything that's going to be a part of the for loop must be indented. So you've got this space that happens automatically if you press enter after the colon. So just to show that, after the colon, if I press enter now, print will go further in, which is an indent. I've just added an extra print line, you can see here on line 5, which is going to say finished after it's repeated my code the set number of times, so that you can see that only the things that are indented will be repeating. So I've run my code, and here you can see it's done 1 to 10 again, but then after that, that's when it's said finished. So the next one we're going to look at is how we can use a list. Now we've done lists in the previous video, and as you can see here, I've got a list called fruits, and then I've stored 3 different strings, which is apple, banana, and cherry, and then I'm going to use my for loop so I can then display each of the items in the list. So this time I've called my variable fruit because it makes sense, and then I've said in fruit. Rather than in range, it's going to look in fruit, which is the name of the list. And then I'm going to use print to display, and then display whatever fruit is currently at. So if I run this code now, let's see what we get. You can see it started with apple, then banana, and then cherry, because it automatically iterates through each item of the list.
Another example of using a for loop is if I want to iterate through each index of a string. So in this case, I've stored in the variable name, I've stored the string Mr. Moore. So this time I've gone for letter, I've got my variable letter, and I've said in name, which is the variable. And if I just want to use print then and then letter, it will display each item of this string. So let's see what happens. On line 1 is the M, and then it's iterated and gone round and done the R, then it's done the space, and so on. It's done each index of that string. So the for loop is a very quick way of repeating a section of code and doing something a set number of times. And in this video, we're going to be looking at something called the while loop. The while loop is another example of iteration, which is condition controlled. We're going to look at a few different ways on how we can use the while loop to our advantage to make our code more efficient. So in last summer's exam, there was a really important question that loads of students got wrong, and it's the description about what a while loop actually is. That word true at the end is what people lost the mark on. A lot of people said until a condition is met, which is a little bit fussy of the exam board, but actually you need the word true instead because it shows your full understanding of it. And then that loop will repeat until that condition becomes false. Most of the time we will use a while loop when we don't know how many times we want the code to be repeating. So unlike the for loop, which is the count controlled one where we can say we want it to repeat this many times, it can repeat as many times as you need it to. So to begin with, I've got a variable which is called password, and it's going to allow the user to enter the password because we've used the word input. So they can type something in and press enter. Now the way it's laid out is quite similar to a for loop, but instead of the word for at the beginning, we're going to use the word while. And this is what this first line reads as: while the password, which we've entered, is not equal to Python123, which is the password, it will do what's inside the loop. So in other words, if they get the password wrong, that's when it's going to start this condition. And in this case, it's going to say incorrect password, try again. Anything that's indented, very similar to the for loop, is a part of the loop. And when I say indented, we've got this little gap at the beginning, which has appeared because we've got the colon at the end of the line. So if I just bring this up here for a second, after the colon, when I press enter, you will see it will automatically indent. Let's give this program a go and see it in action. So I've hit run, and you can see in our shell at the bottom it says enter the password. Well, I'm going to purposely get it wrong and put the password is Mr. Moore and press enter. So at this point we've entered the while loop and it says incorrect password, try again. So again, it's waiting for me to enter the password. So this time I'm going to put purple monkey washing machine, which is a common password, and it says incorrect password, try again. So let's get the password correct. I'm going to put Python123 and press enter. You can see it's then exited the loop and it's gone on to the line 7 on here and it says access granted. Now if I just delete line 5, which is where they get another attempt at having to go at the password, and then run my code, let's have a look what happens. So it's going to ask us for the password. This time we're going to get it wrong again. We're just going to put king as the password. We'll press enter and watch what happens. So you can see it's saying incorrect password, try again, but it keeps on saying this. It's now got stuck in something known as an infinite loop. So including the input again inside the loop is very important in this example because that means they will be able to re-enter the password until they get the correct password. Now this isn't fantastic program design because what if they never know the password and they're stuck trying to attempt that password forever? So let's call our variable counter and we're going to set it to 1 at the beginning because they've already had one attempt at the passwords. So I've changed my code around a little bit to make this work, and we'll just go from the top so you can see how we've got this working. So the program begins by them entering the password like before. So we've got a variable called password, input's going to let them type in their password, and the counter at that point is going to be set to 1 because they've had one attempt at it. Now, while the password is not equal to Python123 and the counter is less than 3. So we've got two conditions that it's checking here. At that point, it will say incorrect password, try again, and it lets them try the password again, which is all part of the while loop. And then our counter will increase by 1 because they've had another attempt at it. So this while loop will keep repeating, and if they've had less than 3 attempts, then at that point it will break out of the while loop, and then it will do the second part using selection like we said earlier. And if they got the right password, it's then going to say to them access granted. But if they didn't get the right password, then it's going to say too many incorrect attempts, you are locked out. So we'll run our code, let's see it. So enter the password, I'm going to try hello, incorrect password, try again. I'm going to try gate, incorrect password, try again. I'm going to try monitor. We had 3 attempts and now it says too many incorrect attempts, you are locked out. We'll run it one more time, enter the password. We're going to get it wrong once. We'll try hello again, but this time we're going to do Python123 and it tells us access granted. So for this one, we're going to use some Boolean logic, and you can see we've got a variable at the beginning which is called running this time, and our Boolean is going to be set to true. Now you could put while running equal to true with a double equals sign, but there's no need on this one. When using Boolean logic, you can just put while running and it will do the exact same thing. We're asking them, do they want to continue? If they put yes, it's going to iterate again, and then it will repeat and ask them that same question. But if they put no, that's when it's going to update our Boolean and it's going to change running to false. And in this case, it will end the loop. So let's run the code and see. So do you want to continue? Let's put yes. Do you want to continue? Yes, yes, yes. But if I say no, it tells us the loop has ended. A final while loop example is a little bit similar to how we've used a for loop in terms of doing a counter. And in this case, we've set a variable which is x to 0. And it's going to say while x is less than 3, it's going to say hello. And after each time, it's going to increase x by 1. Let's see this one working. So you can see instantly we've got hello 3 times. Today we're going to be looking at the techniques called div and mod, which is generic terms for whole into division and returning a remainder in division. These look a little different in Python, and we're going to be looking at examples of how it can be done. So when we hear the word div, this is talking about whole integer division. So if you do a division and it was going to have a remainder, it won't show you the remainder. It's only going to show you the whole number. Mod will only give you the remainder. So it will still do the division and it will calculate it, but then it will only show you the remainder part of it. Let's have a look at it in Python and see why it's useful. So to begin with in Python, this is what it looks like. Normally we do a division with just 1 forward slash. But to use div, we're going to use 2 forward slashes. Now 10 divided by 3 would give us 3 remainder 1 usually. But let's run this code and see what happens. So you can see it's only displayed the number 3. It's just completely ignored the remainder. This might be useful if you're calculating time and you want to split it up and you want to say it's this many hours and this many seconds. And you could say this part of it would be the hours section. To use mod in Python, this is where we use a percentage sign to do this. Now I've gone for the same calculation here. We've done 10 mod 3. So like before, we said it's going to be 3 remainder 1. But let's run the code and see what happens. So this time you can see it's just displayed the number 1, which would be the remainder. Like I said earlier, this might be useful if you're trying to split the information up and you only want to display the seconds part of it, which would be the remainder. But we've got a better example about how this could be really useful. So I've got one more piece of code that I'm going to show you and how we can use this to our advantage. And in this case, we've stored in the variable num the integer 8. And we're going to say if the number mod 2 is equal to 0, then it must be even. Otherwise, it's going to display odd. Now, what this code is doing, it's going to see that when we divide it by 2, if it's got a remainder or not. If it does have a remainder, then it must be an odd number because it doesn't divide exactly by 2. But if it has no remainder, then it must divide by 2, meaning it's an even number. So let's run this code a couple of times so we can see this in action. So the first time I run my code, you can see it's displayed even. That's because 8 is an even number. So let's change it to 9 and run it again. So you can see this time it's displayed odd, and that's because it had a remainder. It didn't divide by 2 exactly, meaning it was an odd number. And today we're going to be looking at file writing in Python. More specifically, we're going to be making a text file using our Python programming. We're going to look at the different modes that you can open it in, including the write mode, append mode, and read mode, and how we can use them all. File writing is a nice technique that we can actually use to store things permanently that were done in our Python program. Once a Python program finishes, your variables will disappear. So let's say that you've done a text-based game, you've got a high score. Well, at the end of your game, that high score will be gone. So what you might want to do is write it into a file. That way, when you start the game again, you can read from that file, so you've got all your stored high scores, and you'll be able to display, say, a high score. Another reason we might use file writing is if a user has inputted something, maybe it's like an entry form to enter their name or something like that, you can store that kind of information in a file as well, so you can read that in when you run the program again in future. So here we have our little program which is going to do some file writing. I'm going to talk you through line by line so you know exactly what's going on here. So to begin with, we've got file equals open, and then we can choose the name of the text file that we're going to be looking at.
So this one I've got inside speech marks, I've got fruit.txt. And then you can see we do a little comma, and inside another set of speech marks is the mode that you're going to open this file in. Now I've gone for a W, which means it's going to open it in write mode. And if the file doesn't exist, it's actually going to create the file for me. If it already does exist, it's actually going to overwrite everything inside it. So that's important to keep in mind if you're going to use the W in write mode. So just to prove that it doesn't currently exist, here is the folder that I'm currently working in, because when I run this code, this is where it's going to create it. So we've got some more lines of code underneath it. We've got file.write. Now what that's going to do is going to put this string inside the file. And you might have noticed that inside the speech marks, we've got \n. Now what that does is it puts the string onto a new line. Otherwise, it will just look like everything's concatenated, even if it's on the line below like this one is here. So the first string it's going to write to the file is going to say, I love apples. And then on a new line, it's then going to say underneath it, I also love oranges. Once you've finished writing to your file, it's always good practice to do file.close and then open close brackets. So at this point, I'm going to run the code and let's see what happens. So it appears on the shell and it looks like nothing has happened. But if I just close that and then go onto the file, you can see we've got this text file now that's existing called fruit, like it was named here in the Python program. And if I just double click on that so we can look at it, you can see, I don't know how well you can see, let's zoom in a little bit. You can see I love apples, I also love oranges on the next line down. For the next example, we're going to look at file writing but in append mode. Now when you append something, it means it adds it onto the end of it. And the mode that we've changed it to, you can see we've got a little A inside the speech marks now this time instead. So like before, I'm going to use file.write, and I've put the \n at the beginning this time because we've already got existing strings, so it'll just put this onto a new line. And this string is going to say, come to think of it, I love grapes too. And because I'm finished what I'm doing with it, I'm going to do file.close. Let's run this code and see what happens. So again, the shell appeared, it looks like nothing's happened, but if I just close that, double click on my text file, you can see it says, I love apples, I also love oranges, come to think of it, I love grapes too on the next line down. So now that we've got our text file and we've got 3 strings that are stored in there, I'm going to show you how you can read from a text file. So to do this time, we're going to put an R in our mode part of it. So R is for read mode. So we're going to use print, which is to display something which we've used before. But you can see after that, we're going to use read line, open close brackets. And then we've got another set of brackets because that's for print. Now when we use readline, each time we use it, it actually automatically goes to the next string along in the file itself. So I've used 2 print lines so we can see it's going to do the first string and then it will automatically do the second string because I put it on the line below. So let's run our code and see. So we've got I love apples, I also love oranges, and they're being read directly from the text file. Important point to make that when you finish reading from it and when you're finished handling your file, you're then going to use file.close again with open close brackets to say that you finish with that operation. A final technique that we're going to look at is very similar to the last one, but instead of doing line by line, what we're going to actually do is read all of the information at once using the technique called read lines with an S on the end. Now this is a little different this time because what it's going to do, it's actually going to store it in a list. And we've looked at lists before. It's where you've got one variable that stores multiple pieces of data. So we've called our variable lines, and then I've done file.readline so that it puts all of that information that was in the text file into a list. So just below it, I've got a print line, and I've said whatever is in this list called lines, I'm going to print whatever is in index 2. Remember, it's a 0-based index, so it'll do what's in position 0 first, then 1, then 2. So let's run this code and see what happens. So straight away, it's gone to say, come to think of it, I love grapes too. And that was because it was the 3rd line down in the text file. So 0, 1, 2, which is the 3rd line down. If I just delete the 2 in the brackets, let's run it one more time. And you can see what happens, and it'll display it like it does when we just print a list. These are all the items that are in the list because this is what it's read from the text file itself. In this video, we're looking at subroutines. Subroutines include procedures and functions. We're going to look at the differences between them, and we're going to look at examples about how we can use them to organize our code better and reuse it when we want to. A subroutine is just a generic word for procedures and for functions. When we design a procedure or a function, it's usually to do a specific task, but what's really good about it is that you can reuse that code whenever you want. For the written part of paper 2, especially in section A, they can ask you what the difference between a function and a procedure is. You will have to be able to describe it for your section A, but you'll also have to be able to perform it or write it down for your section B. So quite simply, a procedure does not return any value. And it'll become clear what we mean by that when we look at our example. But it's still designed to do something. So it's like a section of code that's got a specific task and it will be carried out, but at the end of it, it doesn't return any information. Whereas a function, on the other hand, is another section of code that we can use and we can call. But what's important about this one is that it does return data at the end of it. And we've got a keyword for that, which is return. And we're going to look at that example as well in Python. So we're going to start with a procedure, and we've got another keyword that we're going to look at today to do a procedure or a function, and at the beginning of it we're going to write the word def, D-E-F. You'll notice that this one's changed to orange, and then afterwards when you type the name of whatever you want your procedure to be called, it's going to change to blue. Python syntax means that we need to put an open close brackets at this point and then a colon at the end of it. And we're quite familiar that if we do a colon, when we press enter, it's automatically going to indent, which means that anything that's indented is going to be a part of our procedure. And quite simply in this one, it's going to be a welcome message. We've got print, so we can display some information, and it's going to display the word hello. Now, because all of this is in the section of code here, this block of code that we've named welcome, this is known as local. This can only happen when this section of code is being run. Now, if you want to activate that section of code, you'll have to call it, and then it will run that bit of code. So the correct term, like I said, is call. And to call a procedure, we just need to name it. So we're going to write welcome in this part underneath the code, open close brackets. What that will do, it will call this procedure, so it will then run what's inside it. Let's see it working. So we're going to run our code, and you'll see it will just say hello. So just to recap, this is the procedure here. It doesn't return any information. It just displays the message hello in a string because we've used print. And to call that section of code, we've used welcome. You can have as many procedures as you want, and then you can call it in whatever you want by doing something like this. We've put this in a global section, but they can also be called from inside another procedure as well. Now, there's quite a lot of keywords that we're going to use in this one, so get yourselves ready. This is an example of a function. Now, I mentioned earlier, the thing that makes it a function is that it returns information. And you can see at the bottom of this one, we've got return area. So that keyword return is what's going to make this a function. So we've got a full understanding of this. Let's have a look at this line by line. To begin with, we're going to make our function by using def at the beginning of it. We've named this section get area, this block of code. And then inside the brackets this time, we've actually got two words in there. We've got width and height. These are known as parameters. Your parameters will wait for information to be passed to them so it can be used within the function. This function is going to perform an action. We've got a variable called area, and it's going to do whatever width is multiplied by the height. And then at the end of it, once it's calculated that, it will return that area, and it's going to put it inside a variable that we've got here called answer. So this line of code is really important because we've got our variable answer, and then it's going to activate our function get area, and then you can see we've got our numbers that we're going to pass to it that it can use. So we've got the number 5 or integer 5, and then we've got the integer 10 as well. Now, because these are going to get passed into the function, these are called arguments. So we've got 5 as an argument, we've got 10 as an argument. They're going to get passed into width and height. So the 5 and 10 can then be used here and here, and then that information will be passed back using return, and at the end of it, it's going to display the answer by using print. Let's see if it works. So once we've run our code, you can see it's displayed 50, which 5 multiplied by 10 is 50. So it's done this calculation within the function, and then it's returned the information back into this variable, which we can then use here. So all of this information was part of the function, which was local, but once we returned the information, it went into this variable, which is global because it's not inside a function. So then I can use it anywhere in my code because I've actually stored that information now, which is why I was able to then display it using this print statement, which is where answer is. I want to show you how we can use a couple of different techniques that we've looked at in the past and how we can incorporate those into functions and procedures into like a proper little program. So let's have a look at this line by line. At the very top is the global part of it. I've got import random. That's because I want to be able to produce some random numbers. I've then got a function which is called guess game, and as a parameter I've got secret number, which means I'm going to pass some information into this parameter so we can do this part of the code. I knew it was a function because it's got return in it. I've then got a separate section of code which is just a procedure that I've called main, like the main part of my program. This is a procedure because it doesn't return any information. As part of my global part of my code at the bottom, I've got main open close brackets. So when I run this code, the first section of code that's going to be run is the main section. It will then produce a random number using random.randint between 1 and 10. And I've got a variable called results, and then I'm going to activate the function guessGame. Now at the moment, I don't know what random number has been produced, but it was stored in X. So I'm going to pass that argument up into this parameter because I've put it inside these brackets here. And at this point, this part of my code is going to run, and it's going to display the message, guess what number I'm thinking of. At that point, we've just used a regular input, and it says, enter a number between 1 to 10. So the user will then type in a number and press enter, and it will return whatever their guess is. Now it stores that in the result because that's what we originally set out to do when we sent that information in an argument over to guessGame. Now their guess at that point was a string because we just used input. So what I've done down here is a simple if statement, and I've converted it by using casting into an integer, and it's going to say whatever that result was, it's going to get compared to X, the original number that was produced. So if it's the same as X, you got it correct. But if not, it will say unlucky, the number was, and then display the results. Let's run this code and see what happens. So guess what number I'm thinking of, enter between 1 to 10. I'm going to go with 6, best number. Press enter. Unlucky, the number was 4. That is unlucky. Let's run it one more time, see if we get it. Enter between 1 to 10, 3. Unlucky, the number was 9. I could be here for ages. So just to recap, functions and procedures are a really good way of organizing your code. You can reuse any section as many times as you want. And for your exam, we need to know the difference between the local and global part of our code, and the difference between a function and procedure, which is that function returns information, your procedure doesn't. Today we're starting to look at defensive design in Python programming. And the first of these topics is anticipating misuse. When you anticipate misuse of a Python program, it's because people make mistakes, they type the wrong thing. It might be that they try and break a program because people do that. So this is getting ahead of the game. It's about making your Python programs a little better so that you anticipate those mistakes that can happen. So some example of misuse or people breaking the code on purpose include leaving inputs blank. So when it asks the user to type something in and they don't type anything and just press enter, maybe they're being a little bit too hasty. That's something that could go wrong, and we want to be able to predict that that could happen and prepare for it with our Python program. It might be that you've used int, you've used typecasting, you were expecting the user to enter a number, a whole number, but instead they accidentally put in a word because they've misunderstood what it is that they needed to type in. And it might be it says put something between 1 to 3 and they accidentally press 4, and as a result it wasn't what you were expecting them to type. But in this case we're going to expect them to type the wrong thing, and I've got a couple of examples in Python so you can see the kind of things that we can do to prevent these. So in this first example, it's just a really simple one. We're going to ask the user to enter their name. And on line 3, you can see that we say, if the name is equal to blank, which is just used by 2 speech marks with nothing inside, so an empty string, it will display a message to them saying, you must enter a name. Otherwise, it's going to say hello and then the name that they've entered. So if we just run this code now, I'm just going to press enter without typing anything in. And you can see the result we get, it says you must enter a name. Much better than a big error that's popping up. It's a better designed program. If we run the code one more time, but this time I'm going to type in Chris and press enter, it says hello Chris. So it's working great. It doesn't matter what we type. As long as we type something, it's going to accept it. But if not, it will tell them you must enter a name. So we've anticipated one thing, that they might put a blank by accident. In our next example, we're going to think about if they accidentally put something out of the range that we were expecting. And in this case, we're going to limit them to only picking one of 3 options. So in line 1, we're getting them to enter an input. It says enter a menu option between 1 and 3. So this is already better because the string that we are displaying to them is telling them exactly what we're expecting. It should be between 1 to 3. So just by wording your program better, it's helping. On line 3, this is a common mistake that people make, so we're just going to talk about it. It says if the choice is not equal to 1 and
then you've got to write choice again. People forget to write this variable here. If you forget that, you will lose a mark in your exam. So it's really important that you remember that one. So if the choice is not equal to 1, and the choice is not equal to 2, and the choice is not equal to 3, it will say it's an invalid option, which means it can only be one of those 3 options. Otherwise, it's going to say option accepted. Let's run it and see it's working. Enter a menu option. I'm going to go for 4. Invalid option. Run it again. If I choose 2, option accepted. So we force the user into only being able to choose one of those 3 options. In terms of what authentication means, it's where you're going to check that the user is who they say they are so that they can use the system, get logged in, and allow them on. So most commonly used when people are logging in, you might see it with things like online banking, and quite often when you're in school, you might need to log in as well with the school system. We're going to look at a couple of different ways we can do this in Python. In this example, we're going to check that the user has entered the correct username and password, and only if they've got both of them correct will it allow them access. In this example, we're checking that they've got both the correct username and password. If they've entered them both correctly, it will allow them access. If not, it will tell them they can't enter. So on lines 1 and 2, we've got 2 variables which are storing what the correct username and password are. So the username is Mr. Moore, the password is ABC123. Nice and secure. On line 4, we've got username equals input, and it asks them to enter their username. Line 5 is something similar, but this time they're going to enter their password. Now the authentication comes here on line 7, which is where it's going to check if the username matches what it's looking for and the password matches what it's looking for. So if the username is equal to the correct user, which we set on line 1, and the password is equal to the correct password, which we set on line 2, only then it will say access granted. Otherwise, it will say access denied. Let's run the code and just double check it's working. So it's asking us to enter a username. I'm going to get it right first time. We're going to do Mr. Moore all together. And then it's going to ask for the password. I'm going to do ABC123. And it says access granted. Let's run this code again. So this time we'll enter the correct username of Mr. Moore. But I'm going to put ABCD1234 and press enter. And this time it said access denied. So even though the username was right, the password was incorrect. So it's displayed access denied. So it's working correctly. It's authenticating us. We'll do it one more time and see it the other way around. So this time I'm going to put Mr. Space Moore and press enter. Enter password. Well, this time I'm going to put ABC123, which is correct, but it's going to tell us access denied. That username wasn't right because it wasn't expecting a space to be in there. So this is just one example of authentication, but we can improve this code because if someone's going to try and brute force this and keep guessing, they might eventually get there, and we don't want that. So to improve our authentication, I've got another Python program that's just a little bit stronger and will only allow them a certain number of attempts before locking them out. So in this example, it's a little similar to the code, but I'm only asking for a password this time, just to shorten the code really. But you'll get the point because they're only going to have a certain number of attempts before it tells them they've had too many attempts, and that'll be the end of the program at that point. So on line 1, we've got a variable called attempt, and we're going to set it to the integer 0. Line 3, we are going to use a while loop. While attempts are less than 3, which means they've not had 3 goes yet, it's going to do this. It's going to allow them to enter the passwords. So on line 6, if the password matches ABC123, it will say access granted and then break out of that loop. Otherwise, it's going to say incorrect, and it will add 1 onto our counter, which was the variable we set on line 1. It will then loop, and it will then ask them again to enter the password, and it will repeat that. But if they have too many attempts, it will just kick them out, and it will say too many attempts, because on line 13, if the attempts are equal to 3, so they had 3 goes, too many attempts. Let's check it. So enter the password. We'll get it wrong first time. Hello. Hello. Hello a third time. Too many attempts, and the program finishes. So at that point, we've been locked out. So our authentication is working. Let's try it again. This time we'll get it wrong once, and then do ABC123. Access granted.
So again, our authentication is working because when we did get it right, it didn't keep asking us to enter a password because of this break on line 8. And it just means that we come out of that while loop and can continue on. Today we're going to be looking at the defensive design technique of validation. I've got a few Python programs to show you, and we're going to talk about the different types of input validation. Now, if you see the word validation, it's important that we understand what it is that it's talking about. In the latest exam, students were asked to be able to describe different validation techniques. So you needed to be able to name them, but then describe what they would do as well. It was a 4-mark answer. Techniques that you could have listed included a range check, a length check, a type check, or a format check. So by listing any 2 of them, you would have got 2 marks, and being able to describe them, you would have got the extra mark that goes with it. So I think what's best to do is show you a Python program that uses them so that you understand what each of them do. And then that way you'll be able to describe it if you're asked to, but you can also spot it, or you could also spot it or write it if you've got that on one of your algorithm questions or one of the programming ones in section B. So the first program we're going to look at is a range check example. So it's a simple program. It's just going to ask the user to enter an age. Now for our range check, we've got it so it says it's got to be between 0 and 120. It's very unlikely people are going to live over 120. So line 3 is our important line here because this is where the range check actually happens. So in terms of describing it, it's got to be between a particular range, meaning that the user won't be able to enter anything outside of the range. So this reads as if the age is less than 0 or the age is over 120. Just to point out, like I did in the other video, this second variable here on this line is one that a lot of students forgot. It was a separate question on the exam and lots of students lost an extra mark because they forgot that one there. So in this case, as long as they put a number in anywhere between 0 and 120, it will say age accepted. But if it's anything outside of that range, it will say invalid age. Let's run it and double check. So enter an age, I'll put 20, press enter, age accepted. Let's try and put a negative number, -10, invalid age. Let's try some boundary data, let's go for 120, age accepted. 121 though, invalid age. So we've successfully done a validation technique, which is a range check. The next validation technique we're going to look at is a length check. So let's say that a user's been asked to enter a new PIN number for their bank. And the PIN number's got to be 4 digits, no less, no more. So in this case, it says enter a 4-digit PIN. Line 3, again, is where the magic happens today with the validation technique. And it says if the length, len is our keyword in Python, so if the length of the PIN matches with the double equals 4 and the PIN is digit. Now we've not seen is digit before, but this is checking if it's only used numbers. If it only includes numbers, then it will accept it. If they try and put a letter in there, it's not going to accept it. So if it matches both of those conditions, it's going to say PIN accepted. But if not, it will say invalid PIN. So let's run it and see. So enter a 4-digit PIN. I'll put 1, 2, 3, 4. PIN accepted. Let's run it again. This time I'm going to do 1, 2, 3. Invalid PIN. Wasn't long enough. Let's just try that a bit too long as well. 1, 2, 3, 4, 5. Invalid PIN. Let's go for 1, 2, 3, A. Invalid PIN. Doesn't like it. It's not all numbers. So what you can see we've done here, we've done a couple of techniques. We've done len, which is checking the length of it, and it's got to be 4. That's our validation technique right there to check the length of it. But we went one further on this one, and we used this nice little piece of code, which is digit, to check that it's only including numbers. The final validation technique that we're going to look at today is a type check. And we're going to make use of that digit again to check if it's the right type of data. So on line 1, we're asking the user to enter a number. On line 3, it's going to check that value, and we're going to check that it's a number. If it is, only then it will convert it into an integer using typecasting, and it will display this message: you entered the number, and then whatever number they've entered. But if they didn't enter a number, it will say error, that was not a number. So let's run the code and see. Enter a number. I'm going to go for a whopper number. You entered the number, and it's fine with that. Let's try it with something really short as well. 6. You entered the number 6. Whereas if I put some numbers in and do a letter, error, that was not a number. Let's try it with only letters.
that was not a number. So the isDigit's working really well here, and it's checking what we've put in is a number, and at that point the typecasting's then displayed it, which is a great way of using a type check. So remember, you need to be able to list the different types of validation techniques and describe them, but it's great to be able to use them in a Python program and see it actually working as well. Now, while we're looking at variables today, it's a good time to talk about something called maintainability. Now, this is just good practice while you're programming. Other people might look at your code, and it makes sense to make your code really easy to understand, so it's nice and easy to read and they know exactly what's going on, and that's what's called maintainability. Now, the way we're going to do that is by using nice neat code, and we're going to leave some spaces in between things, which is known as white space, to make it just easier on the eyes to read. I'm also going to show you today how we can add a comment using hash so that you can explain what is going on in your code. So if, for example, somebody's looking at your code and they're like, I'm not sure why they've done that, you can explain that in a comment so they know exactly what your thought process was. Sometimes that's also a good idea if you couldn't get your code to work, and you can leave a comment and say, this is what I've tried, can you help me with this section here? And they know exactly where to look then. Finally, like I said, we are going to be using variables today, and you can call a variable anything you want, but it makes sense to call it something that is related to what it is that you're storing, which will just make it so much easier when somebody else looks at your code, because they'll know exactly what it is being used for. And also for you later in your code, if you're going to refer to it, it's easier for you to remember, which will just speed up the whole process. So we're going to start off by adding a comment, and to do this we're going to use hash. Following hash, we can just type in whatever the comment's going to be that other people might want to read. My comment is going to be global variables, to let other people know that this is going to be the set of variables that I can use anywhere within my program. So now I'm going to start putting my variables in my program. I'm going to start by naming one surname, which I think is a really appropriate name for the information I'm going to store. I'm going to store inside a string Mr. Moore. And you can see that I've got speech marks both sides of it, so it's turned green, which knows that it's going to definitely store a string within my variable. Surname is the variable. Mr. Moore is the data that is being stored within the variable surname. What I'm going to do is output my information just to make sure that what I've typed so far hasn't got any errors in it, which is a really good way of testing your code, and it's good practice as you're developing a program just to keep running your code so you can see if it's working correctly. So, like from the last video, we're going to use print to output some information, and then going to put my variable surname within the brackets. Let's run our code to see if it outputs the information correctly. So I'm going to run my code, it's going to ask me to save it. I'm going to call it variables example, and as you can see, it's displayed Mr. Moore, so it was outputted correctly. So we're going to look at storing some other data types now. We've already looked at the data type a string. Now we're going to look at what we call an integer, which is a whole number. So the whole number that I'm going to store is the house number. Notice I've put two words together, and just so you can see the second word, I've put a capital N there. This is a technique known as camel case. So house number equals 54. Now notice I didn't put speech marks on this. I've just put a number, which means that Python will recognize it as a whole number straight away. So the variable house number is now storing the integer 54. The next data type we're going to look at is something known as a float or a real data type, which is a decimal in Python. So for this one, I'm going to call my variable hours worked, and I'm going to put 8.5. Because you've got the decimal point in there, Python will automatically recognize it as a float, and that has been assigned to the variable hours worked. Finally, we're going to look at a data type known as a Boolean data type. The Boolean data type can hold the true or false value. This is really important for different techniques that we're going to look at in later videos. So my variable for this one is going to be employed, and I'm going to put the word true. Now notice that true has got a capital T on it. This is following Python syntax. This is not a mistake, which is why it's changed color, because Python recognizes it. It would also work if I've done a capital F on false. Now I just want to point out the maintainability technique that I've been using throughout. You can see we've got some white space here underneath my comment. We've also got some white space here after my variables before my print statement. This is just good programming practice so that other people will be able to easily read my code. I've also used suitable variable names for all the information that I'm storing, which just lets other people understand what my code is supposed to do. If I'd put x equals 8.5, that could have meant anything. Whereas we know that hours worked means how many hours somebody's worked. It's just much so easier to understand. So we're going to finish by combining the two techniques that we've talked about so far. We're going to output some information and put a variable at the end of it. So I'm going to write nice to meet you, speech marks,
I'm going to put a comma, which is Python syntax. It's following the rules of the programming language. And then I'm going to write surname, which is the variable I want to put after my string. Have a guess what it's going to say when we run our code, and let's see if you were right. So it says, nice to meet you, Mr. Moore. So it's used the stored information from surname and put it at the end of our string.
And that today we're going to be looking at different types of test data. We're going to discuss why we carry out testing, the different types of testing. Then we're going to have a look at some examples of normal data, boundary data, invalid or erroneous data. When we're creating programs, we have to carry out testing. Testing is really important to make sure that your program is working as you expected. And if you're designing the program for somebody else, to make sure that it meets the requirements of what it is that they were after in the first place. So there's two types of testing that we need to know about, and the first one is called iterative testing. Iterative testing means that you're going to carry out some tests as you are developing the program itself. You might add a little bit of extra code, and then you're going to run your code and test that that little bit is working correctly. You might do this if you're trying to spot mistakes early, trying to debug as you're going, so that when it gets to the end of it, you're less likely to have as many bugs. Final testing, which is sometimes called terminal testing, is carried out at the end of the software development. This means that you've got everything completed and you're ready to try different types of data in there to make sure that it still gives you the output that you were expecting. So usually with terminal testing, you try different types of data, especially when there's different inputs, to make sure that it's working as you expected. The first type of test data is normal test data. This is where you're putting values in that the program expects. So if it expects a number between 1 and 10, it can be any of those numbers between 1 and 10. Boundary data is a little similar, where it is classed as normal, however it's right at the edge of what should be accepted. So if it was something between 1 and 10, you might put in a 1, you might put in a 10. That's at the very boundary of what should be accepted. Finally, you've got invalid or erroneous data. These often get paired together, but they're actually slightly different. Invalid data shouldn't be accepted by the program. It might be that you put in a -1, and at that point, in our little example, it would mean that it would come up with a little message if you programmed it well to say, that is invalid, please try again. Erroneous data means that you're putting in the wrong data type. So if it was expecting you to put in a whole number, an integer, and you accidentally type in a string, then it shouldn't accept that because it was only looking for you to put in a number. Let's look at a few examples of this in Python. So before we type in the different types of data, I'm just going to talk you through what this program is actually supposed to do so you get it before we actually try it out. On line 1, we've got an input and it's going to say enter an exam score between 0 and 100. If the user successfully types in a number, which is what our line 3 is doing, it's checking is it a number that they've put in with our little is digit, it will then convert that into an integer on line 4. At that point in the program, it's going to say if the score is over 0 and the score is within that and 100, so between those two, it will display a message saying that that score has been accepted. Otherwise, it's going to display a message saying that that score is not valid. It must be between 0 and 100. Finally, it's going to say invalid input if they've not put in a number. This is our erroneous check to make sure that it shouldn't accept anything unless it's a whole number. And it politely asks them, please enter a number. So at this point, this is our terminal testing, or final testing, which we're going to do right at the end of this program to make sure that it's working. And we're going to do that by testing out different inputs to make sure that our test data is either accepted or not accepted. So the first time I'm going to run this program, I'm going to put in some normal data. I'm just going to go for something in between 0 and 100. I'm going to go for 45. The score has been accepted, which we expected the program to do because it was normal data. This time I'm going to go for some boundary data, and here it needs to be between 0 and 100. So our first boundary data for this would be 0. That score has been accepted. Let's try it again with some other boundary data. This time we're going to go for the other end, 100. Score accepted. So far so good. Everything's being displayed as it should. Finally, we're going to go for some erroneous data. I'm going to type in a string, which is the words 100. Invalid input, please enter a number. So this has been a well-designed program. None of the things that shouldn't be accepted were accepted, and it's displayed a suitable message after all of that. Today we are looking at Boolean logic. So as a definition about what Boolean logic actually is, it's a way of working with two values, which is true or false. This isn't all of the logic gates that we can use for this, but there's only three that we need to know for our exam, which is and, or, and not. And you can combine these to change the values that are output at the end. And in terms of why we do this, we use it to make decisions in computer programs, which controls things like lights turning on or off and so on. Now another part of this is something called a truth table. And let's say we've got two inputs going into one logic gate. Well, a truth table shows all possible outcomes. Now in our exam, we will need to be able to both draw a logic gate / logic circuit, which is multiple combined, and we need to be able to draw a truth table and fill it in correctly. These span anywhere between 3 and 6 mark answers, so this is one that we need to know. So the first logic gate that we're going to look at is the most simple one, which is called the NOT gate. And this is like a triangle with a circle on the end. If you forget your circle, you'll lose a mark, so you need to remember the circle on the end of it. This one's fairly straightforward because it's only got one input and one output. Whatever goes in, the opposite comes out. So if it was a 1 going into a NOT gate, it is a 0 coming out of a NOT gate. So the truth table for this, which you can see at the bottom, is relatively small. The column A represents the input. So the input for A could be a 1 or it could be a 0. And because it just flips it, column P is the output and just shows the opposite of what went in. Now the NOT table can be written in a couple of ways for the expression. So you can see in the middle it says P equals not A, or you could write P equals not A, but it's drawn a little bit differently. So instead of the word not, we've got this strange little symbol. It has been used in an exam before, so you need to recognize that, as that also means not. The next logic gate we're going to look at is the AND gate. This could be drawn as P equals A and B. So there's two inputs this time, which is completely different from the NOT gate. And like before, there's a different symbol that you can use to represent it. It looks like an upside down V, this one, but it means the same thing. It means AND. So our truth table is a little larger on this one, and that's because we've got different combinations about what could be going into both A and B, and then what the possible outcome is. Now the rules of the AND gate is only when all inputs are a 1, the output will be a 1. So you can see for the first 3 rows of the truth table, all outputs of P are 0 because there was at least one 0 in one of the inputs. But then you've got both A and B are both 1s, so the output is a 1. The final gate that we need to know is the OR gate. So this one could be written as P equals A or B. So again, you've got two inputs like the AND gate did. It could also be written, and it looks like a capital letter V, but it also means OR. So P equals A or B, but with that little V looking thing, which also means OR. Now notice that columns A and B are exactly the same as they were in the AND gate, and that's because we show every possible outcome. So they are exactly the same, but then column P is what is different, and that's because of the rules of the gate. So for the OR gate, if at least one of the inputs is a 1, then the output will be a 1. So only when both A and B are a 0, P is also a 0. All other possibilities, the output is a 1. So what I've done here is I've joined a NOT gate to an AND gate. And notice that the input for the AND gate comes directly from the NOT gate. So in terms of the expression for what this would look like, it would say P equals not A, and you put the not A inside brackets. After the bracket, you would put AND B. If you're asked to write an expression, usually you would put not inside brackets. If we're drawing the truth table, you can see we've got an extra column in this. The extra column is to represent what comes out of the NOT gate. If a 0 went in at input A, like we know from the rules of the NOT gate, that would flip, which means in our column of not A, you would see a 1. Columns A and B are exactly the same because that's all possible things they could be. We're filled in column not A based on what is going into the input A, but then that will have to feed into the rules of the AND gate. So output P, at that point, you would just follow the rules of the AND gate. So only if all inputs are a 1, the output will be a 1. So you can see on our second row is the only time there will be an output of 1. And that's because both inputs going into the AND gate were a 1, which follows our rules for the AND gate, meaning that column P will be a 1. Okay, so we've got a couple of questions to practice on this topic. So that we're getting some practice with those weird looking expressions, I've used them for these practice questions. I'll read them out loud so that you know what I'm asking you to do. So draw the logic circuit for the following expression. Not A or B. And the second question is draw the logic circuit for the following expression, which is not B and A. Okay, let's go through the answers then. So the first one was draw the logic circuit for the following expression, not A or B. So it would look like this. So you've got A going into the NOT gates, and then you've got both feeding into the OR gates. Maybe you could have a little practice drawing the truth table out for that one as well. And for our second answer, draw the logic circuit for the following expression, not B and A. This is what it would look like. You've got B as the input going into the NOT gates, and then both of those inputs are going into the AND gates.
Today we're going to be looking at the difference between high-level programming languages and low-level programming languages. We're going to look at a few examples of each and describe the characteristics of them as well. When we talk about different programming languages, we can categorize them into either something called a high-level programming language or a low-level programming language. The main difference between these, though, is that high-level programming languages is very close to normal English, which means it's very easy to understand. When you're looking at it, you can often recognize the different words in there. You can see the different syntax on there, like your speech marks and your brackets and so on, and it's just much easier for somebody to look at and read. Low-level languages, however, are not close to the human language. They're either going to be machine code, which is just binary, or something like assembly language, which we'll look at in a minute, and they are very hard for people to understand. So as I mentioned earlier, high-level languages are very similar to the English language, which means that when we look at it, we can read it very easily, but we can also write that code much easier as well. As we mentioned in our testing video, that means that when we are looking for any errors in there, we can debug it and maintain that program much easier. Most often, high-level languages are what we call portable, meaning that you could take that program and put it onto another device and you'd still be able to edit it on there as well. A downside of having a high-level language, though, is that it needs to be translated into a machine code so that it can be understood by the device itself. So every time you run a high-level language, it gets translated before it can be run. So some examples of high-level languages will include things like Python, which most of us are really familiar with. We've got Java, C#, and Visual Basic, or VB for short. So low-level languages are closer to machine code, or they are machine code. And a big bonus of that, it means that it can interact directly with the computer's hardware. If you were asked on your exam for an advantage of low-level language, you could use that as one of the advantages. So as I mentioned earlier, machine code is the lowest level of language, which is just binary. Machine code could be executed directly by the CPU, which means it's really fast. Binary, for the majority of people, or machine code, is really difficult to be able to read and write just by looking at it. Different CPUs use different machine code. It might not work from one to another. Another common low-level language that gets talked about is something called assembly language. Assembly language is really low-level language, but it's not quite machine code. It does require an assembler to be able to translate it, that last step, into machine code. Assembly language uses mnemonics, which are little short blocks of code which we can use to actually write assembly language. Assembly language is still much faster than a high-level language, but it's definitely harder to write and maintain, unlike the high-level programming languages. One of the most common questions that you get asked in your exam is to do a comparison between low-level languages and high-level languages. All of these characteristics that we've looked at so far are really good to be able to say high-level languages do this, low-level languages do this. Any of these ones for assembly language are all relevant and accepted on a mark scheme. Here's a little example about what assembly actually looks like. Here we've got two mnemonics of assembly language. We've got our first one, which is move, MOV, and the A is talking about an address, which is just a register on the CPU. The value 5 is going to get moved into that address. This next one is as simple as it looks. Add, which means it's going to add the value 3 into whatever is already being stored into the previous address. So the result of this one would be 8. Linking this to some previous topics, low-level languages will be getting used if you are wanting to directly control the hardware. It also gets used when developing operating systems or embedded systems. You may also see it if you're programming different device drivers. Today we're going to be looking at the difference between compilers and interpreters. We're going to look at characteristics of each and then advantages and disadvantages of each, which are the most common questions you'll be asked on your exam. So compilers and interpreters come under one category, and that's known as a translator. If you're writing code in a high-level language like Python, your code must be translated first before it can be executed, meaning it means to be translated into machine code before it can be executed. The main types of translators include compilers and interpreters, and we're going to look at both of them. So if you're describing a compiler, it translates the entire program in one go before it can be executed. Unique to a compiler, it produces a separate executable file, which means it's a separate file that you can double click on and it will run that code. This makes it great for sharing so that you don't have to share the original source code once it's been compiled. Once your program's been compiled, you will get a list of all the different errors that are in your code. And then if you make any changes to your code, you'll have to compile it again so that it is a new executable file. So the advantages of using a compiler include that the programs themselves will run faster once they've been compiled. That's because they don't need to be translated again, they can just be run straight away. And as I mentioned earlier, that source code isn't needed anymore. You've already got the file which is being compiled. So you can share that with other people. That's a massive advantage. And it also means big companies don't need to share the original source code once they've sold it. So as a disadvantage, if you've got a lot of code, it can take quite a long time to compile the entire code. And also if you've waited a long time and then you've got a ton of errors, then you've wasted all that time. So it's a bit of a disadvantage that it only shows all of the errors once the whole thing is being compiled. Now an interpreter is different because it's going to execute it one line at a time. Now each line gets executed immediately, so it's going to reach that line, it's going to translate it and then execute it. If it comes across an error, at that point it's going to stop and it's going to display what the error is. So an example of this is Python, and at the end of it there's no executable file being produced. Interpreters often get used if you're going to be testing your program. So advantage of an interpreter includes being easier to debug because those errors are found immediately and it's going to stop and you'll know exactly where the error is. This makes it really useful during program development and testing. The disadvantages of an interpreter include programs generally running slower because the translation happens every time. And also, unlike the compiler, that source code has to be present. So if you were a big company and you wanted to sell your code, you're going to have to share the source code with it. Most commonly on your exam, you'll be asked to compare the two. Sometimes you can be asked for the characteristics of it, but most of the time you might be asked to do advantages and disadvantages of either a compiler or an interpreter. Today we're going to be looking at what is an IDE. We're going to be talking about the different tools that an IDE has, including editors, error diagnostics, runtime environments, and translators. So when you hear the term IDE, it just stands for Integrated Development Environment. This is just a place where you write your code. So idle when you install Python is an example of an IDE. And the one that you often see me using is one called Thonny. You might use a different IDE. It's just a place where you're going to write your code. So you probably already know some of the features of the one that you use where you've been practicing your programming, but we're going to run through them because we need to be able to describe them for your exam. All IDEs come with their own little tools that's going to help developers write their programs. These tools include things like editors, error diagnostics, a runtime environment, and having translators. Now the editor itself is where you're going to be writing your code, and there's loads of little things that happen that's going to help you when you're writing code. One of the most important ones is syntax highlighting. Now we know that syntax is the rules of the programming language and following those rules. For example, if you type a word like print in Python, if you've not spelt it correctly, it won't change color and you can see straight away that you've probably made a mistake. Other things change color as well, a bit like a string will change to green in Python if you put your speech marks, just making it easier to see that you've done the bit of code right or to spot any errors. In some IDEs, a bit like Thonny, you get little suggestions. So if you start typing a word like print, it will suggest any words, any keywords that begin with P, and you can either double click on it or usually press something like enter or tab and it will just write out the rest of the word for you. This is really useful if you're trying to speed up your programming and you're typing really fast. In most IDEs, especially in Thonny and idle, if you do a colon and press enter, it will do an automatic indent. That's the little gap that goes after things like for or a line with if and else. The following line needs to be indented because that's Python syntax, and by automatically doing that indent, it will not only speed you up, it'll make your programming look cleaner, and it will help if you've forgotten it as well. Be careful of mentioning this last one, but line numbering is also considered to be another benefit of having an editor. But if you write line number on its own and don't follow it up with a description in your exam, you won't be awarded the mark. But if you write something like line numbering, because this will help you locate errors, then you will be awarded the mark for that. Another tool of an IDE is something called error diagnostics. This is especially going to help when you're debugging your code or testing it. This would include highlighting any syntax errors that you've made. This might be you've run your code, but then like your bracket that's missing or something will be highlighted at the end of the line to sort of say this is where the error is. Quite often when you run your code at the bottom, you might see a big red message if you've got an error. Now sometimes, as we know, these aren't always really useful, but majority of the time, if you know what you're looking at, it's quite useful because it will say something like there's a problem with your string, or it's not followed a syntax rule, and then you know what the error is a little bit faster. In the same place, it usually says the line number where the error actually is. Not always 100% accurate, but majority of the time it does say something like line 6 syntax error, and it could say some suggestions with this. Another tool of an IDE is having a runtime environment. In idle, this will be the shell, so that when you run it, the shell will then open on another window and you can see your code running to make sure that it's working correctly. In Thonny, you don't even need to save your program. It happens just underneath so that when you press that little play button at the top, you can see your code in action to make sure that it's working. This is great for testing your code while you are developing it. You might write a little bit of code, run it, test it at the bottom, make sure it's working correctly, make sure it's giving you the results you were expecting. This is great for testing for logic errors as well, because if you run your code while you're developing it and it doesn't give you the output that you were expecting, you know that somewhere you've got a logic error. Finally, another tool of an IDE is a translator. We've got a full video on different translators, but we're going to just recap it really quick. A translator is when you've got your high-level code, something like Python, and it gets translated into machine code so that it can be executed. This is another tool of your IDE being able to do this. And the two that we discussed is a compiler, which will translate the entire program at once, and an interpreter, which will translate it line by line, and it will stop if it finds an error. And that's it for this one. I'll see you next time.